All right, so for you, this is a brand new video. For me, I'm just continuing talking. Did you know iPads, you cannot pause the video, you can only stop it? That's dumb. Anyway, that's my rant for the day. You miss those, don't you? Don't you miss my rant of the day? There's always something ticking me off, isn't there? All right, so you had to do 41 to 45, I believe. Yep. So I likely will do this in a couple of videos just so that it's not a 3-hour long video and you can kind of choose. Maybe I'll do 2 examples and then another 2 and then the third one. Maybe I'll do something like that. If I see one's particularly long, I'll just do that one. One of the questions that was asked is how come we have to do all this work if we already have all the information that we need in the question? My answer to that is if you think you already have all the information that you need, you're probably doing it wrong because you probably don't have all the information that you actually need in order to do it. So if you're like, I already have all the information I need, I don't need to figure out this over here in order to figure out that, maybe, but maybe you're doing it wrong too. Not sure. That's why we're going to make these videos to find out. All right. So number 41. Number 41 says you have a 12.5 gram bullet. So mass of the bullet is 12.5 grams. And I'm going to put grams there so I remember it's in grams. It's shot into a ballistic pendulum. We talked about the ballistic pendulum yesterday. There's my very fancy, I don't know if it was yesterday now. Oh my word, my days. There's my fancy ballistics pendulum. So it says that ballistics pendulum, so mass of the pendulum is 2.37 kilograms. And that's in kilograms. The pendulum rises a distance, so I'm going to put H for height, you can put D for distance, doesn't actually matter, of 9.55 centimeters. And the question is, what was the speed of the bullet? So what was the speed of the bullet right before it hit? Okay? Now, I don't know if some of you are thinking maybe I can just do one of those formulas that says like distance is 1/2 g times t squared or something. I don't know whether you're thinking there's some formula that you can use. The problem is a bullet is not going at a constant velocity. When you fire it out of the gun, it's going really, really fast. As it travels through the air, because of air friction and gravity, it slows down. And so the velocity is not consistent throughout. Neither is the acceleration consistent throughout. And so you can't just use one of those straightforward formulas. That's the problem. All right, so they want to know right before the bullet hits the pendulum, how fast was it going? So again, it's like a collision. Two things are colliding. So I can look at the momentum, the millisecond before the bullet hits the pendulum and the millisecond after it hits it, in order to figure that out. But you're going to see the problem with that. So if I wanted to go straight to the end, okay, because I know what I want to figure out is going to require me to look at the momentum directly before and the momentum directly after. So I want you to see why I can't just use this. So I'm going to start here so you can see what's missing, okay? So the mass of my bullet. Now, I can't have these in 2 different units. So this is going to be 0.0125 kilograms. So mass of the bullet, 0.0125. Velocity of the bullet, right before it hits the pendulum, I don't actually know. So I have to leave that blank. That's what I'm trying to find. Plus, mass of the pendulum is 2.37. And before the bullet hits it, it's just hanging there. It's not moving, so its velocity is 0. Sorry, this is the before. I don't know. Before, after. There we go. All right, so right after, not after it's swung up, because when I look at momentum before and after, I'm talking the millisecond before the bullet hits and the millisecond after it hits it. Not once it's already gone up. That's too long a time. We're talking about the instant before and the instant after. So after, the bullet embeds in the pendulum, so they're now one thing. So the mass of the bullet has to be added to the mass of the pendulum. The problem is I don't have a velocity. I don't have a velocity of the bullet and the pendulum together right after they hit. I don't have that. So now I have two things I don't know. So if I need to figure out this one, I need this information. So how do I get that information? To get that information, I have to think about what formulas do I know that has velocity in it, when the velocity could be changing. And one of the things I know is that once the bullet hits the pendulum, it's all kinetic energy. It immediately is moving. So it's all kinetic energy until it gets up here. And then it is gravitational potential energy. And it's not moving for a second. And then it starts swinging back down and swinging back and forth. So what I know is that right when the bullet hits, it is all kinetic energy. Once that pendulum swings up, it transfers all to gravitational potential energy. So I have 1/2 mv squared is equal to mass times gravity times height. Now in both cases, the mass is the bullet and the pendulum together. So I can put that number in there if I want to and work it out, but I don't need to, because if there's 1 m here and 1 m here and they both represent the same mass, I can just cancel them out. So I have 1/2 v squared is equal to gravity times height. Now height you have to change into meters. So there's 100 centimeters, so 1, 2. So 0.0955 meters. And so when I worked that out, so basically I multiplied this side by 2, I multiplied this side by 2, and then I took the square root, I got that my velocity was 261 meters per second. So this is actually 261 meters per second. No, I lie to you. I lie. I look in the wrong spot. My apologies. I looked in the wrong spot. I did not get that. I got 1.37. That makes a whole lot more sense. I was like, that doesn't make sense. 1.37 is what I got. Try that. That number will work better. Now I only have one unknown. I have the velocity of the bullet, because that's 0. So I add these two, multiply by 1.3.7, divide by 0.0125. That's where I got 261 meters per second. And again, it's a bullet. It should be going fast. If you didn't get a big number, I would question it, because a bullet, being a bullet, moves fast. I'm going to stop here. I'm only going to do that one because my husband, who very kindly made supper because I was in a staff meeting forever and was sleeping this afternoon because I had a migraine, and now I'm recording videos for you. So he made supper. He's come to tell me supper's ready. So I'm going to go eat, and then I'll record a couple more videos, okay? Bye.